Hello and welcome. A microphone might be helpful at the beginning of the stream, but yeah, that's fine. You're probably all right. So, at the beginning of every stream, I'm Ginger Bill, and I need to post this places so where people know where to go. I know I'm on, not just relying on Twitch to tell people, because that doesn't always work. Let's go on to the into places. Right, let me see. Where else can I post this stuff? Yeah, that'll do. That'll do, I think. Right, good evening, everybody. Oh, yes, I know. Oh, it is indeed a party. It's a party when I'm here, obviously, wearing my... It's a different shirt to yesterday, but different... Same overshirt, obviously. That's the thing. I was trying to think, I should have one every day. I'm like, nah, I'm liking this jacket. It's nice. The overshirt's nice. So how is everybody doing? Good, good. So today we're going to just probably program for an hour. Literally no more than that. Because life. But yes, so things should be going very well. And... stuff. Hello, welcome. Welcome to the chat. Will I cry if I want to? No. I can't let myself do it. Cannot do it. Cannot do it. So, to get people up to speed again, if you've not been watching the streams, I have been working on the Odin compiler and specifically working on the Tilde backend for us. It's a brand new backend. So Odin, for people who do not know, is the programming language that I develop. And it is the data-oriented language for sane software development. So this is a C alternative for the joy of programming. So it's mainly for like game development, graphics development, tooling, that sort of application development, all that lovely, wonderful stuff. Now, at the moment, we currently use something called LLVM. LLVM is this backend that many compilers use. So many C compilers like Clang and C++, Rust uses it, and got many other languages out there. But the problem is, LLVM is pretty much the only out there if you want a optimizing backend which doesn't have a silly license and also can target most platforms. There is no other alternative. So, because there's not many alternatives out there, I was thinking about making one of my own initially. So I was thinking, oh, I was going to make my own, that'll be all right, yada, yada, yada. And then I was going to start it up. That was the thing, as most people knew. Most people knew I was going to call this. Well, I didn't name it this, but we came up with that C0 project. Most people got confused by the name. Had to explain what it was. But I've personally kind of abandoned it, but not exactly. And we've now gone towards something called Tilde. So Tilde is the backend used for the quick C compiler made by my friend Negate, and this is a really fast C compiler with a complete new fast toolchain that's meant to replace, again, it says GC, MSVC, and LLVM. So the backend I'm using is the Tilde backend, which is here. And it's very, very nicely designed because it's very, very fast. It's heavily multi-threaded. Now, compared to LLVM, LLVM is really, really slow. People don't really understand, why are you trying to replace LLVM? So I'm not. LLVM is still going to be in the Odin compiler pretty much for a very long time because we want it to be. We still need that for loads of reasons. But we want something to be faster, and we want something so we don't have to be reliant on LLVM if we can. And the reason for this is, well, LLVM is slow and takes up about 90% of the entire compile time in even like small builds. Even in big builds, it gets even more. That's how slow LLVM is. So Odin itself should be a very fast language to parse, type check, semantically check in general, and compile and build. But no. This is because of LLVM and also partially the linker. Once we've done that, the linker stuff is another thing to tackle, but there are other options on there. Like getting Mac, Apple developed a new linker, which is pretty fast. If you're on Linux, you can use the mold linker developed by Rui. And on Windows, you're kind of a bit screwed. Sorry. But yeah, there is now the wonderful things regarding all of this. So shall we get back onto this? And if you've got any questions, please feel free to ask them in the questions in the chat, where they're above me, up here, legally. They're up here on the stream, but they're on, again, if you're on Twitch, they're clearly over there, but like, I can't, whatever. They're wherever you're looking at, they're over there. in the Twitch chat, but clearly above me if you're watching it wherever, or if you're previously. So there we go. Let's get back to stewings. I've been doing some stuff in the background, obviously, because I have been working on this, and I'm not trying to just not work on it. So one thing I've been working on is some of the constant global system at the moment. The constant global system is a little bit different. So the way that Tilde works is actually much better. Also, it can be a bit restrictive compared to LLVM, but it is actually just much better in every regard, and I'll explain why. So let me look for the global create. So when you click a global variable, it's very simple. You just create one, you set the length, name if you want it, the debug type, and the linkage. Most of our stuff is going to be private, it's not a problem. Then we can set the storage for this global. So this tells you which data section it is, like is it the text, the read-only data, the data, or the thread local storage? Is it past the global, size of this storage, the alignment of this storage, and the maximum objects. The objects is how many places can you write to. Now this is the very special thing. This is where it's clearly closer to how the hardware works, obviously. Not hardware, how the executable formats work, sorry. But it's a little bit different to LLVM. So LLVM has a type system, but its type system gets in the way. So in this way, there are two ways to different regions. You can either just add a region, which gives you a memory buffer back that you can write to. And then the other one is you can add a symbol relocation. So that just gives you the pointer to another symbol and put it into that location. Again, depends on the pointer size, but yeah, pointer size being 4 or 8 bytes, depending on the platform. That is kind of what we're going on. So as a result, I was asking, I think there might be one thing I might be asking for from Negate is, would it be possible, I'm not sure if this is a good thing or idea, by the way, it's something I'm thinking about, to make the max objects variable in length, because you don't always know it beforehand. But at the moment it's just predefined, and I understand why it is predefined. That's not a criticism, it's just I understand why. So how far along is the Tilde backend? Technically you can create an XE, but it's a bit weird. The problem is we can do all the adding, no problem. Like this is really easy. Like a lot of the expressions are in there already. The control flows in there, minus like the for in loops. We haven't done them yet. We've done the normal for loops, the normal if statements. We've done switch statements, type switch statements. Yeah. This is how far along we are getting. I'm working on the global constants at the moment. The problem is printing, or more generally, calls. So this is something, I mean, Negate, we're going to have to work on. This is going to probably be the bottleneck I'm going to hit tomorrow. So this is something I'm going to have to work on the TB compiler for, because we're going to have to figure out how do we convert from the values and pass it through the ABI. And that's a really hard thing to do, and I'll explain why. So we'll just do this in C rather than writing in Odin, but let's just write C. Let's say we have foo, we have int x, float y, bool z. This is absolutely fine to deal with. That gets passed into a register, that gets passed into a register, and that passes. These are all passed directly, no problem. Let's say we have this other data type here. Let's say we've got struct foo, and it's very large. So let's just put it as in, I know, 1024. This is very large. This is obviously, when you do foo, passed here, yeah? This is actually identical to doing foo x equals star doing this. That's what it is. It's really passed by pointer, and then the call E side takes a copy of it, in C at least. In Odin we don't need to do that, but that's what it does internally. So this is an indirect pass, right? These two things, we still need to handle this. Like we need to handle is it direct or indirect, and how do we pass those parameters across? The problem, and this is the real problem here, is what about the cases where you have this stru? We've got on Windows, this is not really much of an issue because Windows is really simple to deal with. But when it's come to System B platforms like Linux or Mac, we have to worry about how something like this gets passed. So we have, let's say, a vec4 float x, y, z, w, void vec4v, let's say, just call this bar, sorry. How does this get generated? What code does this generate? Well, this is not passed by pointer. This is actually passed into a register. So it's effectively, you've got some SIMD register in here. So it's like a SIMD register. Let's just do an Odin syntax for the time being. like this. That is exactly how it gets passed, which is a little bit like, wait, what? It's like, yep. So it's direct, but it's not easy to convert. So you're going to have to figure it out. And the thing is, it spans up multiple registers in this case. So it is actually multiple things. So the question is, how do you make this easy from an API standpoint about converting this to be useful for the user? Because the user just wants to pass the vec4. The vec4 gets distributed across the right number of registers, because it could be multiple registers, not just two, just one, or one big one, or multiple there. So how do you design this from an API standpoint? And that's just passing to the procedure. The next one is retrieving it from the procedure. Like, how do you go from this to this? Because you can't really just do a bit cast. The easiest, the trivialist way, obviously, is to make a copy of it. So you do that, and then you do a mem copy. V, this is the results. This is like the passed in one. So you do V, and then you're like, yeah, that doesn't work. So you can't do a mem copy, but you will have to do like maybe a cast or a store. So maybe you can pretend that this is the SIMD thing and make sure this has the right alignment on it. So I'm writing this as if it's C, guys. Set syntax to C, so let's do it. Align as, line as doesn't even pop up now, but align as does, whatever. Say that's 16 bytes. Then we just want to go cast this to the correct type. So let's call this a SIMD for F32. Let's call that parameter that. Take V as your thing, dereference it, and then store V star in there. That's what you're going to have to do to get it back out. But clearly that's not making a stack allocation, when really you probably don't even need the stack allocation for most operations. So then you have this kind of design issue going on about how you do it. So you have ones when you're passing the parameters in, but also getting the parameters into the body. So the caller and callee things, and they've got to be handled in certain ways. For Windows, this is trivial because the Windows Win64 ABI is really simple. In fact, I can describe the entire Win64 ABI to you right now. All events and all floats are passed in registers, kind of, like passed directly. I shouldn't say registers, let's just say they're passed directly. If a struct is of size 1, 2, 4, or 8 bytes, this will be passed as if it's a register of that size, so passed in directly. Any other size data structure, anything else, will be passed indirectly by pointer. That is the Win64 ABI that I've just described to you pretty much. Wonderful. That's how trivial it is. System V is a nightmare in comparison. Now, System V is clearly an extremely empirically well optimized thing for most use cases on those platforms. And I completely understand why that's the case, because the Win64 one is not very fast. So you have to have this kind of thing on it. And you have to deal with it. So yes, does Odin have its own ABI? Technically, yes. And the reason is, the way we can define Odin's ABI, just to explain to people, let's say you've got, this is how it currently works. This is not necessarily how it will work in the future, by the way. You have to be very careful about this. This is just how it's going to work in the future. This is just how it currently works. Let's say we've got a parameter here. Let's just do an I32, and then it returns an F32. I'm going to call that one. I'm just going to name the return result just to make it a little bit clearer. F32, I know, U32, and then we put W as a bool, okay? This is the foo we could have defined. Now, what is this actually equivalent to? So really, this is actually equivalent to, let me just write it. If I wrote this internally, like that's actually what those have the exact same signature internally, by the way. This is how the Odin calling convention works, by the way, the Odin one. And if I want to be even fancier, if I put context list in here, this, the implicit context pointer, gets passed in here as last parameter. So this is actually the same thing. So we've got all these multiple things, the multiple return values, that get separated. We may change this in the future for performance reasons. We need to figure it all out. But this one for multiple return values seems to be the best one possible. So the rules for the moment are, they don't always do this. So this is where the thing is, if the return value can be returned in a single trivial register, it will do that. It doesn't need to have them passed by pointer. It will just do it as a single register because it's damn simple. But if it isn't possible to do that, then we'll just try and pass them as multiple parameters and do this. So this is what these get expanded out as. If that makes any sense. Because we find in practice, the reason why we do it this way is because the last parameter usually is like an int, a bool, or like an enum, which is an int really. And these are like small things easy to pass to trivial, but the things before it are usually the bigger thing, like usually a struct of some sort. And if because it is a struct of some sort, that is what you kind of want to pass on. You don't need to have to do this stupid rigmarole. You have to always pass it by pointer anyway for the consistent ABI. So that means in this case, Odin's ABI is technically an extension of C's. We still do the exact same thing as C. The thing where we differ from C is that all of our input parameters are actually immutable, or assumed to be immutable. That's a better way of putting it. So let's say we have the equivalent, some like, let's say call this bar, and this is in C, by the way, struct, we just call it big bar. Yeah, big bar. This in C, as we knew, is pass it by pointer here, and then it actually gets a copy, yeah, in the callee. Now, when we go to Odin and we wrote the thing, this is not how it works. So if we do bar B here, this is big bar, yeah? This is not what we do in Odin. This is, so in C, Odin we do this. Big bar, that parameter is kind of equivalent to it, like the equivalent of doing, if it's big, and only if it's big, by the way, doing this in C++. It does a const reference, which means it is a pointer. It doesn't make a copy, a variable copy in the state. It's just a const pointer. Const reference in that regards, because all of our parameters in C, or Odin, sorry, are all equivalent as if they're const. So that's one thing there. So that's kind of a nice little optimization you get. Clearly, there may be some issues there in the partial issues you may get clearly with ABI and stuff if you don't know that optimization. But it's most of the time it means you don't need keyword const at all in Odin, which confuses people because many people go like, "Oh, Odin, it's all it's mutable by default," and it's like, "Yep," and it's like, "Yeah." So it's very weird, but the reason is we don't need const in Odin, technically speaking. So what I mean is, I'm a C programmer, clearly by profession, C++. And one of the things is that when I've written const, there are actually only like 3 reasons why you'd ever need to write const in practice. The first one is for strings. So it's always a char const star kind of thing. And the reason why you want the char const star is because you kind of want it in the read-only data section, and that's fine. And that's it. Because once you created a string value, by the way, it is immutable. You're never modifying it. And if people say, well, what if I want to modify it? I'm like, then you weren't created the value yet. You've got they're still building up the string. And if you're still modifying it, you may be doing some weird optimization hacks, which are not really necessary on multiple machines now. I'm not saying you have to allocate loads of memory. I'm just saying you're still building up the stream. And I like making that distinction. So in Odin, we just have a string type, and you can't insert to its field. Like its fields are immutable. So that's what we did all there. We don't have to have const, just strings are immutable, done. Problem solved. The second one is const to denote input parameters. So in C, it's very common to have like a const star to say, hey, this is a pointer going in, and it's an input only. It's not in out. If you get rid of the const, it could be in out, or it could just be out. It's usually in out. There's that case. Then there's the second last thing, which is I'm trying to think. Sorry, the second last thing is the last thing. Some people use const just for static const, like static const. Const t, like that. This is so you need to make sure this is really in this read-only data section of global. There are 3 uses I use in const. They're the 3 I ever use in C. Some people are like, oh yeah, but I don't want to use variables. I'm like, yeah, but in C, it's kind of like I've never found me that writing const actually helped me, like to be productive. That is a very weird thing to do. And that is, I know, is controversial. Many people love the immutability by default in many different languages, and that's great. If it helps you solve great problems, that's great. I don't really. It just never helped me solve those problems for me. So because when I came to design owning, I went, okay, why do I need const in the first place? Like, okay, so the first thing is strings, making them mutable. Parameters, assume their input are always constant, so therefore you don't even need to denote which are the input and output pointers, because the input pointers are already const, but that means actually they're output pointers in that sense. Makes sense. So then the input ones, you can just pretend everything's const reference, because that's the optimization you can do. And also we have slices already in Odin, so they are get rid of the need to do like a const pointer to present it as an array. And the last one is to think that when we have an attribute, just say this could be in the read-only sections. So we change sections directly for you. So that makes that problem solved. So it's all kind of really nice to know. So more other things. Let's read the chat. Yeah, so this works the same way in Nim and Jai. I'm thinking of talking about the const reference stuff. Yep, that is the case. It's in many languages nowadays. I think JI does it slightly differently, and I know Nim does it differently slightly as well. There's some minor differences here. Like Nim also does the var thing coming from Pascal. I didn't want to do that in Odin, even though there's benefits to it. I just didn't want to do it because it's very much I wanted to keep it more C-like in that regard and say, hey, pass a pointer, don't just pass it by reference kind of thing. Yes, and he does exploit the mutable semantics. Another one, guys, first time chat. Welcome to the stream. Thank you for coming. Hey man, just wanted to say I'm kind of new to low level programming, and you're really inspiring me to get better and delve deeper into compilers and how they work. Well, thank you. Love the channel and your work, and I'm really enjoying your articles on memory allocation. Well, thank you very much for those articles. For people who don't know, I wrote some articles on memory allocation strategies on here. I probably put a link. That's the wrong thing I clicked. I meant to click this. This is some things here, and it's teaching you about memory allocation, so you can think in a different way to programming in many ways. So this is, hey, modern machines work differently. They have virtual memory, and there's different ways of thinking about your allocations and stuff, like the size and the lifetime and such, and how we do our own custom allocators. And I even explain my own custom approach right up from the front. And then we're going to learn about all the different things in the series. Like the first thing we learn about is linear allocation, or arenas as I call them all the time. And arenas are the simplest allocator, and in fact the most most popular custom allocator that you'll use. In fact, what I use for everything in my personal use. Like if I need anything else outside that, I need to build a free list, or maybe I want the just general heap allocator that they give by default. But in general, the beauty of like an arena is it correlates with a lifetime. There's another good friend of mine, Ryan Floria, on arenas, and he has understanding lifetimes, the arena allocator, and he's explaining how, again, extending stuff like from we all kind of agree on all the stuff. This is what happens with your friends. We kind of learn all these different things here, and what we learn, and he explains again how an arena is coupled up with the lifetime for its allocation, and arenas are a much better thing. So the best thing about arenas are you allocate all these things up, and then you free everything that came under that arena all at once. This is the thing about manual memory management that people may not always understand, is that manual memory management is easy. Like, well, it's really complicated. No, it's only complicated if you have all this loads of bookkeeping and you have to make sure to free things when you're doing it correctly and so on and so forth. But really, it's not actually that difficult. Yeah, it's something else, yeah. There's an attribute for the read-only data section. That definitely solves that bit for me. There is an attribute for that. There's an attribute just to write to which section you want to write to. You just say it's the section attribute, and it tells you that link section, and you just set the attribute in there for you. It's the attribute for the link section. You say which section you want to write to. That solves that problem. Yeah, pretty much. So you build up that. You could set VS Code skipped send telemetry 1 to avoid extra crap. Yeah, you could, but we don't. I'm using the really old one, which doesn't even send the telemetry. Like the script I'm using doesn't even do that. Yeah, but nice to know, nice to know. Thank you very much. Right, should we actually get to programming, or do people just like this discussion day today? Because it's very more like relaxed day. It's a bit cloudy today, so that's why it's a bit darker in here. So it's a bit more glum. Oh, a bit drab outside. Compared to the rest, apparently Europe has been having a heat wave, and we've just been like, oh, got to 20 degrees today. That's warm. It's not, at least it's not raining. Oh, it's fine. I'm not using VS 2010. No, I'm using like 2020, I think now. But the command line thing I'm using doesn't do. It's weird. Don't ask. Like it technically doesn't even really work for me properly because I don't call the right command line script. Shh. Old habits die hard. Okay, they die hard. So, shall we explain what I've been working on last night? Because none of you saw this on stream because I was programming not on stream. So this is let's go down to here. So this is generating some constant values, but this is constant global values I'm trying to do. And what I've been doing is, we'll say look at compound literal. So compound literal, for people who don't understand, is actually, you know what, I've got the demo, which is actually the thing I'm compiling. It's something like this. You have a struct in here, and you are filling in its parameters. This is a compound literal. Yeah, very simple. This is a type, and this is the compound literal. It's like the filling in of this thing. If I do this, it's just the name thing. This is the equivalent of that. and it fills in. This is no debug printing of this yet, but I think what I'm writing is fine. It's pretty easy. So what I'm doing is go to the global const comp literal, so compound literal. Yep. We pass in the module, so that's the translational unit we're doing, the original type, the exact value, which has all the magic things in it, the global, which is the global we define for it, and then with the base offset, because this is a recursive function. We love recursive stuff, makes things easier to deal with, obviously. And then when if it becomes a performance issue, then we can always hook it out and put it into a for loop, no problem. Because that's the beautiful things about anything that's recursive can be usually put into a for loop. Yeah. So arenas are pretty much, anytime you have, I recommend reading the article series, that usually helps, but I think arenas are pretty much, when you have anything that has allocations together, and they're all allocated together, they share the same lifetime, that's when you're using an arena. You think about in lifetimes of allocations, and things start getting simpler. And you start realizing, oh, I could probably use an arena here, and like, oh, you use arenas everywhere now. Oh, have an arena per lifetime. Oh, problem solved. It's kind of what it is. And you can have a hierarchy of arenas as well, and all these beautiful things. But I digress. Yeah, sure. I can just share the link in the chat. This is the second in the series. And I'll share Ryan's as well. There you go. So that's why I keep talking about arenas, because also TB does. I need to clean up the arena use, because at the moment I'm using one arena per Bleeman procedure, which is stupid. Absolutely stupid. Whatever. I need to use one per thread at the moment. Might be the better option. Okay. So, ignore this. The read-only section is only for strings, so you put that in the read-only. Everything else is not going to be constant, but just ignore what I'm doing. So what we do is we create the compound literal, create the thing, and we set up the size, we get the size and alignment, make sure which sections it is, and then we're going to first off check to see is how many elements does this field have? Because if it's got no elements, we know it's completely zeroed. So we don't need to have any sections, like global regions in there, and then we just set the storage and return the global. We're done. Dead simple. No, it's done. But if it has got some elements to it, then we're like, we've got to do something here. So we've got to calculate how many regions we need to do. So this is a recursive thing going through, figuring out how many regions we need to do from the data type, following through the AST in a sense. And this will calculate what we need, and then we set it. Very simple. But originally I'm thinking, I don't know if this is better from an API standpoint that I have to do this, or we should just do a dynamic way of doing things. But again, memory allocation things, it's easier to pre-allocate, because then it's probably faster as well, because when you resize, you're probably just wasting the memory, and you don't necessarily need to do that. Do we have to create IR nodes manually with Tilde? You won't need to do anything with Tilde. I'm confused. What's the question exactly? I don't recommend anyone using Tilde yet. I'm still helping with it. It's still early in development, like very early. But I can see the potential for it to help replace LLVM. That's the beauty of it. I can see it. Much better. Hello. Right. So then we'll say we got the type of the compiler. We'll say it's a struct, and we look at this example, we look at the field things, it's dead simple. We go through all the fields. We then check to see the type of the value we've got, and then actually get the value itself. Check to see if this can be possibly constant. Like, can this field actually be constant? Because it could be a non-constant thing, because some things aren't actually constant. That's the beautiful thing. So, but in Odin, now the new system, we can. It's actually getting there. That's the beauty of it. Because this new system, okay, so explain one of the issues we had with LLVM. So in LLVM, if you wanted to do something that violated its type system, you couldn't do it at compile time. I had to literally assign things to runtime. So a good example of this was when I had a union. Because unions are just like a blob of memory, really. They don't have any types, and because of this, you couldn't really assign data to it in LLVM. So we had to assign it at runtime just before main, and this is annoying because a lot of things like this, especially like we say the runtime type information, has this structure, which means yes, you've got this minor cost, very minor cost on startup, but it's still annoying that you have to do this. But now with this, it's just like, oh, I've got memory. I can write sections anywhere I want as well. Yeah, let's just do this, shall we? And it's just so much easier. Oh my God, is it much easier? Oh, seriously, it's just like an absolute beauty to do. You mean the machine dependent IR representation? Well, yeah, it is no IR is technically machine independent. This is one thing. There's no such thing. All IR is machine dependent, but it's depending on which machine you're targeting. That's the thing. It's the target machine is depending on. But there is an IR dependent, as in it's not like, it will lower down to the right machine code that you want. Okay. So this is beautiful. Like I can just do stuff like anything I need because now I've got proper access to raw memory I can just write to. Oh, I don't have to worry about stupid type systems or their stupid like layout of structs, which I can do my own custom structs. It's useful. So when we add a region, we go through it all. We've got the value. We do all these special checks at the start because there's certain things in Odin's type system which are a little bit weird. Like for instance, this one here is checking for two things effectively. It's checking and say, oh, it's an array of strings because you've got array programming in Odin. But we also allow for strings to be, you can assign a string literal to an array of a fixed length if the same literal is the same length. Yeah, it's a little bit weird, but like it's valid. It makes sense. And again, there's one also if you've got a rune. So these are just edge cases. This one is like, hey, it's an array to a string. This one is, it's just a multi-array, so we can just add multiple regions of the same value to each thing. That's simple enough to do. Matrices, I still need to do this, and that's to do as well. But they're like, again, scalars to matrix, scalar to vector. So these are the scalar things of arrays. This is a string to an array, and then this is a scalar string to an array of strings kind of thing. Ooh, that was a mouthful. But the rest is dead easy. Like, look, oh, I had a region. Here's the memory, and I write to it. At the moment, I've got a cert, assuming it's like little endian everywhere, by the way, because I'm not handling big endian yet. I'll get there, but not yet. So this is dead easy. Like, oh, I just write a boolean to this bit of memory. Oh, what about the integer? Oh, I just do the same thing. I write into that memory. What about a float? I just write to this bit in memory. Oh, what about a pointer? I just write to this bit in memory. Oh, what about a string? I'm like, well, if it's array-like, then I do it. If it's not, then we've got to do it in that region. So this is where you will have two regions you'll have. You'll have the pointer region. So we look at the constant string. Ignoring it here, we have two regions we have to set to. So the first one is the pointer for the backing data for the string. So you have to do a symbol relocation. And then the second one is just some data, so we can just write the length of that string. And there's that lovely beauty going on there. So that's just adding the new regions. Type ID at the end of the day, it's just a point, it's just an integer, so we'll just write an integer. And then we see another compound literal, so we just go through the loop again. Dead simple. Procedures, this is dead easy to do, but I just haven't done it yet. Mainly because you have to generate the procedure, because it couldn't just be a named one, it could also be a procedure literal. So if that's the case, you need to add that to be generated, and then you can get the procedure symbol, the global procedure symbol, to then add it to do a symbol relocation. Complex numbers, just write to memory. Quaternions, just write to memory. And then we're done. So this is all nearly getting there, by the way. There's some certain things I'm missing, certain things about how the patching needs to be done and everything. But this will actually allow things to be so much better. It will reduce the runtime startup cost of many like the global stuff because of LLVM. Literally, I was getting around the LLVM stuff. And this is so much more flexible as well. Like for instance, when we do abandon LLVM like in a few years, not anytime soon, like when we get to 1.0, this is kind of like getting a new backend for Odin is necessary Odin. But once we got to 1.0, we've got stable backend for Tilde. Tilde can support everything LLVM does, and it's better than LLVM as well. We can then start to retire LLVM and start to remove it. That's what I mean. Not yet, nowhere near time. Just be very careful. We're not getting rid of LLVM. Just we're having an alternative to it, not just a replacement. Okay, but eventually we do want to replace it. Just that's in the future, very far future. Just make sure everything's clear. When we do want to go in that vein, we and I'm just trying to think. Yeah, go in that vein. We can then probably start doing stuff which is a bit better for the memory layout because we have a lot more control over what we can do because we were restricted by LLVM struct stuff and saying, oh, we could always just use paddock structs everywhere like Swift does for its compiler. I bet there's no one here who knows how the Swift compiler works, probably other than bits from me. But there is. Hello, Swift compiler developers. Hello. But yeah, I mean, like, yeah, that's one way of doing it. There's also, I think Rust does it as well. But the interesting thing, I'm trying to think. The interesting thing is that we have a lot more control over stuff like this because there is no stupid type system to get in the way anymore. If that makes any sense. So there's that. So that's kind of easy, and I'm still not finished with this all. There's still stuff to fill in, and it's still a bit of a hack at the moment because it's only kind of assuming constant things. So if it can't be constant, then we've got to assign to it. So we still haven't done the globals yet, and there's no way of testing that what I'm writing is actually even correct. And all I showed you was the structs. There's also like arrays you've got to deal with. There's bit sets, which is just an integer, but you still have to deal with it because you could have a compound literal for the bit set. And slices as well. Slices are another thing which they're in memory, but again, these two so that's similar to a string they are in that regard. Hopefully that's or more stuff, I think. So yeah, you've been using Odin for 2 months and it's great language. Well, thank you very much, Christopher. This is the not string Odin string array optimization. This is just like how I'm doing the backend stuff, generating in a string in the memory of the executable. The backend is called Tilde. It's here. This is from my friend Negate. He's working on the Tilde backend for his C quick compiler, is he's calling it here. Yeah, this is the quick compiler. That's good. The line count here is just for the tests mainly. It's not for the code base. Just to understand that. Just the amount of tests he has on there. So hello, welcome to the first person to the chat. It says here, if I may ask, why do you do so many things here starting with GB? So proud of the country code or spreading out? I'm like, GB is Ginger Bill, it's me. I am from Great Britain, but it is Ginger Bill. It doesn't, that's why it starts with the country code, GB. Also, if you're seeing in my code base a lot of GB things, it's because I had my own like library that I've been using for a decade at least at this point, maybe. And it's gb.h, it is. And that GB thing's just Ginger Bill's library. That's what it is. Hopefully that answers you. You're asking because I didn't know that there is an LLVM alternative other than GCC. So there are alternatives, but none of them met our requirements. And GCC does not meet our requirements. Is licensing is first thing. And also GCC isn't great. It's not fast. It's bogged down over 30 or 40 years. It's been there. Yes, it's that old. So I was going to write my own replacement, and then Negate's been working on his, and I'm like, you know what? No, I'm going to help you do this. I'm going to integrate it into Odin, and also just help with his development if I can. Yeah, the GCC ecosystem is too complicated. I've been using the ISI for polyhedral optimization. It's very complex, and yeah, it is. It's very complex. Yeah. Yeah, the GB.h is nothing like what we do. We should just turn it entirely. You're right. I don't think we should put the changes upstream. It's not GB.h anymore. And like most of that stuff we don't even use in there. Like this, I've tried to delete most of it. I can, but like I don't even think we use any of the mutex stuff anymore because we made our own stuff. We've done all that. The printing stuff, the string stuff we still use. Because that's quite useful for the just string building. But that's about it. There's also the just general C standard lib stuff. But yeah, there's a lot of stuff. I don't think I'm programming much today, if you didn't guess. I'm just talking. Just talking. We should have one of those chats. And I should be sitting in one of those jacuzzis, obviously. And because why aren't you just... God, you're on the internet. Why are you watching Twitch for that sort of stuff? I don't get people. Twitch, I'll never understand it. I am a... Yeah, let's not go there. Yeah, the internet. The internet is an interesting thing at the end of the day. And it's full of weird things. But yeah, so I'm thinking... with the generation of the procedure stuff from the literal, we need to generate that, pass it down, and then you've got a write a section in there. Programming, no. And also, in England, with a hot tub, the wrong country for it, really is. Well, I mean by the rain, is what I'm saying. Because a hot tub clearly will be warm for you. Also, God, hot tubs, I've got to think about all the diseases they're cooking in there. Sorry, I'm turning into an old man in a young man's body. That's not good. Hot tub in the rain is nice. No. Right, carry on with some programming. Well, the energy bill as well would be not nice. Yeah, that's true. Yeah, like the energy bill for a hot tub is in England. Yeah, not good. Let's not get into politics, please. Right. Adds to the atmosphere. I'm not sure what atmosphere we're adding to. Oh, the fun days for this. That's fine. Right. So this is kind of what I've been working on. It's still not finished. There's loads of things that like I've still got to fill the holes in. Like if I look at the LLVM stuff, what am I missing from the LLVM? Like, oh, by the way, this is a lot cleaner code than the LLVM stuff. The LLVM stuff is just full of hacks everywhere. Like we're actually merging the like compound literal code. And the LLVM did merge the stuff, and it is mostly mergeable. But I'm still not sure how to deal with the compound literal stuff for local stuff, because at the moment local stuff is pretending it's obviously global. That's all it is. It's not really local. So a good example of this in Odin, and it does make intuitive sense, and this is what people want, so you have to be very careful. Let's say I've got a structure foo. It's got an int in here. Let's say, sorry, syntax, not syntax, what would I just do? Odin. Y, it was an F32, and Z, let's put this to be a slice of ints. Whoops, slice of ints, shall we? Now, if this is a global, so we'll say global, and do foo, x equals 1, 2, x equals 1, yeah, let's do 1. No, let's do 137, I like 137, I like that number. 1 over is close enough to the inverse of the defined structure constant, of course. Let's do this one, let's say 3, that's close to pi. And Z, we're going to just do a longhand here of the types. Let's do, that's 1, 2, no, let's go the square numbers, 1, 4, 9, 16. Okay? So in a global, this is actually equivalent to as if I wrote a global slice, and actually it's not that, it's actually like this. This is a global array. It's got 4 elements in it. 1, 4, 9, 16. Yeah? And then we put the data in here. It's effectively the slice. So we've got the data and then the length of that. Yeah? That's equivalent to what it is. So equivalent internally to that. So you have this global array. Now, if it's a local, so we're inside a function, or a procedure, or whatever you call them, common functions, because that's what TP calls them. Let's say we have a local. Well, the local follows a similar pattern. It creates a local array. Yeah? Equivalent. And it's a local stack array, obviously. And then this becomes that. So that's the behavior that you want. So even though the vast majority of this, and the way you'd actually initialize this, you should probably do the constant, then initialize it with the stuff. Let's say this is like, say, a raw slice. I'm just pretending this is a raw slice, yeah? That is what it gets it done internally. So it's a bit different. So clearly the stuff I've been writing would work that way, and it has, oh, it's been going through a global. I'm like, yeah, but so I could probably unify the code, and unifying that code is probably not a bad idea. But it might make sense to go, hey, is this actually, go through the same code, generate the global variable, and it'd be a constant in this particular case. It can be stored in the read-only section. But then we just copy that onto the get a stack, mem copy that in, and then patch everywhere where it's not constant, if it makes sense. Like this stuff is not constant, this is local to the stack. And that's the way I would like to do it, because that's most efficient. Because the most inefficient way of doing it, unless, and this is a big unless the compiler can optimize this out for me, which I doubt it will be able to, but it could do, is the unoptimized vote position is just to, okay, we'll have foo, so this would be the unoptimized thing. We do local foo, we do an X, and we do a store. So that's a store, another store, and then we do this. So we get the data, local array, and then we do that. This is just internal, obviously. This is not actually how you write Odin. You do that, and that would be the thing. But if you have a massive data structure, those multiple stores compared to just doing a mem copy will get slow. But it is easier to do it that way, obviously, and I might write the first code to do that way specifically. So I've got to be careful. Is the Odin compiler self-hosting? No, and it won't be self-hosting for a very long time, because that's just, it's hell, put it that way. Self-hosting causes more problems than it's actually worth, so yeah, if that makes any sense. Yeah. What's this? Any other questions? Yeah, wonderful. And yeah, the compiler is still written C++ because you want something stable. You don't want to have something that's you're still changing all the time, even if you have bugs and you don't want to rely on that. It's bad enough when I hit compiler bugs like in MSVC or Clang or LLVM. They're bad enough. I don't want to have any more on top of that. Oh, good God, no. Right, so... I think I'm going to stream for another 10-15 minutes at this point. I think it's just a chatting stream today, talking about how things work in Tilde, rather than program, because I think many people were just getting a little bit lost when I was doing it. So at least with chatting, you can learn about how compilers work to a certain extent. It's quite nice. So I think I need to figure out how I'm going to deal with this compared to the other approach, because when it's local, it's going to have to be different to what I'm doing here, because I think I might just have to write the code twice, I'm thinking of. Like, if I do a local one, and I know it's like a slice, and that is a, ooh, you can't do a local slice, then I just say that bit's not patched. So then when I come to do the thing later on, I go, well, I know this was constant, but this wasn't constant, so I can then just assign this as I go along. I think that's what I'm going to have to do. Like, can this be constant? Yes. If it can't be constant, no, don't do it. So there's many different things I'm thinking about. Yeah. Hopefully that makes sense. Other things we were working on the other day, and I've also got working, I don't even think I did show on stream, by the way, but I did talk about it. We go to statement. If statement, switch statements, and for statement, I even got tight switch statements working, for goodness sake. I think we did tight switch statements on stream, didn't we? Yeah, we did. On if statements here, though, sorry, I clicked the wrong thing. If statements were dead easy to implement, and I'm writing them to a certain philosophy here, so I'll explain. With if statement, we'd open a scope for the entire if statement. That's dead easy. We do the init statement here, so we can create init, so it's dead easy to do. Then we're creating all the different control regions, which is in the sea of node SSA based system that we're doing, not basic blocks. Build the condition, which the condition will then check what the AST here is, and then jump to the right branch, depending if it's true or false. Like, okay, so then we go there. We could have a label, so we need to create a target list, so we can always break out of this thing if we need to. And do all the stuff that's necessary here. This is dead simple. Now, I put a to-do in here, but I think I need to ask which philosophy we're doing. Like, should we do a constant check? Like, for instance, if we know that the condition is constantly known, like we know it's at compile time, it's always going to be true or always going to be false, why don't we just generate the code for those particular cases? Like, if it's always true, don't even do the else statement, because the else statement is never going to get ran. But if it's always false, only do the else statement. Don't even do the if body, because that's never going to get ran. So, but there's two conflicting philosophies here. Is it the IR represents what the code represents, and this is what I think we're probably going to follow. Don't do any like optimizations at this level. Do the optimizations further down the line, rather than doing what the IR, what the code will execute. Like, for instance, if it's always true or always false, that code will never get executed. So don't generate the IR for it, even in like debug build, like development builds. But that's where I'm like, I think do what the code represents, because then it's easier to debug. It's easier to reason about when you read the code, like you're trying to, even you're doing the generation. So it's like, yeah, this makes more sense now. And hopefully that makes sense. C++ is stable, yes. I'm still using features from like C++ 11. I don't even really use 14 or 17 or 20 features. So I'm using a 12-year-old version of C++, and not using many of its features then. C++ is stable, like all of the old code works now. When I say C++, I'm talking about the compilers as well. The C++ compilers are stable mostly. I think we have different views of what you meant by stable there. It's just probably the language difference there. What is that defer in C++? So that defer is a defer statement. Now I've written an article on this before, and if you actually write defer in C++, I think before the Stack Overflow, mine used to be number 1. It might be on number 1 on Google actually. No, okay. It used to be number 1, but now it's just number 3 apparently. Okay. But this is mine. This is not even technically the one I use, but it's pretty much close enough to doing it. And it's nice, so I can have a scope exit in Odin, pretty much. No, C++, sorry. Useful. And I have it in Odin because defer is a nice construct to have. Again, that's another link I should probably add to the chat for people to know. Do I use auto? Do I think being explicit is better? So I use auto in certain places, very rarely in C++. And that's usually just to minimize repeating stuff. But because I don't use any of like pretty much any of the C++ features, auto is fine. Like one of the issues with auto is if you're not being explicit, you might not realize a constructor is being called or a deconstructor is being called. But because I don't use constructors or deconstructors in Odin, in C++, I don't usually have to worry about that. I write pretty much C code. Like, look at this. This is C code, effectively, I'm writing, with some minor modifications. Like, this isn't C++. This is perfectly valid C. Yeah. Hopefully that answers your question. Why would someone think C++ was not stable? I'm not sure. I mean, what they mean is there's new additions keep going on with new versions. Like there's new versions coming out all the time. I'm like, yeah, but it's still stable. Yeah, I use null pointer every. So this is the most C++iest thing I probably use. Because null pointer is better than null in my opinion. Because this is the problem with C++, not C. So in C, null is actually is pretty much defined like this. This is in C, yeah, in C. But in C++, null is defined as that. Just 0. Which is bad. And you may think, well, wait, why? Why is it that way? Well, this is because in C, if you have a void star, this can implicitly cast to any other pointer type. But in C++, you can't do that. You can have any pointer implicitly cast to a void star, but not a void star to any pointer. This is only a C feature. And I understand why C++ did it. It's annoying, really annoying, but I understand why C++ did it. They wanted to get more type safety because they didn't want people to be doing like this all the time, which is, let's say we've got some array, and they do, I'm going to do calloc, right? Elms and size, so count size, yeah? Yeah? This is common C code, but in C++, you would need to do a cast, yeah? Because that's not allowed. Now, that's completely understandable why they want to get the type safety. And we do this in Odin as well, by the way. Because in Odin, we allow any pointer to implicitly cast voids, like the raw pointer. We don't have many implicit casts in Odin at all. Most things are very explicit, but this is one of them. This is very, very useful. But we don't allow the other way around. And the reason why is because we have better allocation constructs, like just better ones. Like we have make. We have new. Like I can do make t instead of my version in Odin. I could do this. Or I could do new and I want to get a pointer. I can just go new t. This has the right type for you. So you have generics in a sense. This is why we don't need it in Odin. But why C doesn't need it. So the problem with C++, let's go back to this. Why does C++ have this 0 as it's not? Because of that. But it does allow implicitly converting integers to pointers. Any type. So it allows that 0 thing. So as a result, this is an absolute stupid thing because you can just do unironically null plus 1 in C++ and that's valid. Because it's 0. So C++ went along and said, yeah, we're not going to do that, even though loads of code even relies on this insanity. Literally, it does. Welcome to the world of programming. What the C++ committee came about said, no, we need to have a null pointer type value, which is of null pointer, like null pointer type. And this will be a constant, which will implicitly convert to any pointer. And it's like, okay, this is a 0 value for all pointers and I have null pointer. So this is a feature I use because it actually is better than null, especially in C++. If you write in C code, there's not much benefit really, but in C++, I think C is now implemented a null pointer as well, I think. Something similar to at least in the new, like C23. So hopefully that there. Is there okay, so different things, loads of more questions. Wonderful, wonderful. How does Odin's module system compare to OCaml? Oh, good question. Also on the first time chat. So, oh god, I need to refresh myself on OCaml's module system. But Odin's package system is directory based. So a directory is a package. So in Odin, a package is a directory containing .odin files. So when you import a directory, you import that package. That's it. And that's how it works. And all the files within that thing can see themselves within the package scope. And then you deal with it in that way. So it's apparently it's the best way I've ever found. It took me ages to design this system because I was trying to get around many of the flaws of pretty much every other language, and I researched them. Now OCaml's, if I can remember correctly, because I literally haven't touched OCaml. I've got the thing here just to do a bit of like revision because I can't remember how it works. Yeah, I now remember this, and it's file-based modules. They have both. They have a bit of a. It's a bit random, and it's like, this is my point, that the idea of a package or a module in OCaml is a bit, it is defined, but it's not consistent. And it's not necessarily what you want to do, because there's a problem in, there's a problem in programming that I've found, where if you have a file-based system for your modules, you'll have a file that acts as the organizer of all of them. And also you have usually, I call this the diamond import problem. So let's just get Milton open to explain this. So Milton, this is like it's actually the same diagram actually, what that is, interestingly, but let's just draw it from scratch. Let's say you're creating a package, and I'll explain why this is the case. So let's say you've got a package file and it's in file. Say this was file based and we just have file A. So then whenever you use it, you just import it and it's no problem. That's absolutely fine. Let's say you then want to extend this across multiple files, because you know what? It's very useful to have multiple files when you're organizing code. Like, files are there to help organize. You don't just want one giant one, you may want to separate it. And that separate file may be a different file dependency or something of that nature. So let's say you got file B. Now let's just say B is really trivial. In fact, all that B does is actually imports A, extends it, and then you just import B when you're done. Yeah? Great. Now here's a minor problem with this system. Because this is a kind of trivial system, it's like, oh, you've got to make sure import B and not A as that file. So really you're like, okay, you know what? Really, I need to just have them kind of, we import B, but then we have C, which is the actual package that we import. So everyone always refers to C and these are the things. And you might like, oh, okay. But you may think like, no, you know what? Sometimes I can't do this. Sometimes I'm like, you know what? I want A and B to understand each other. So have a cyclic import. And then C can organize them. But the problem with cyclic imports is they're cyclic. So the question is which gets evaluated before the other. And if you're in a statically typed language, cyclic imports can be a flipping nightmare. Like, they can do them, you can get around them, but like static imports can lead to horrible things. Like allowing it in the small case seems no problem. But I've seen things that just are massive cycles, hundreds, if not thousands of imports cycling together. And that effectively means, so your cycle here is effectively saying this is the package. Everything, if it depends on everything itself, that is a package in itself. It's not one. It's not like, oh, we got multiple things. Like, that is the giant thing. So this means that this thing here is the package. So sometimes if you've got a language that doesn't allow cyclic imports, Odin doesn't, and for very good reason. It's not just it's loads of technical, also practical and everything. You may think, oh no, you know what? We now need to put all of this into another file called D, which then they share the imports from each other. So then the things that are shared go in D, and now you got into this, and now you got C. And it's like, okay, so to create a package with we wanted 2 files originally. We only wanted really 2 files. We've now had to create 2 more, so 4 in total. So this is for the shared stuff. So this is all shared. This is the organizational aspect. Organizational. And then this one's the collection of them all. So then we can just import this final file. It's like, what? Why the hell are we doing this? Because it's not, and this is the best case scenario, by the way. This is not even like going crazy. This is just me. This is the, yeah, this is fine kind of thing. And people think this is sensible. I'm like, you guys are insane. Like, but this is the problem when you have a file-based system. And it is. You'll see this all the time. So Odin went, yeah, we want files, but a lot of the time we do get to the point where actually packages are like multiple files, and it's very, very common. It's not just one file. You have multiple. Organizational purpose, for dependency versions, for platform-specific versions, so on and so forth. So the question here is, how do we improve this? And what you do is you get rid of the shared thing. You make it so that A and B do see each other, but there is no cyclic import. They just can see each other. Yeah? And then you exploit something that already exists. It's called the file system. So that still is organizational. Yeah? And this is already, you have the files here, and this is all already part of a directory, isn't it? So these are the files, and this is the directory. So you already have a hierarchy. Why are you adding another hierarchy on top of a hierarchy? Exploit the hierarchy that's already there. So you don't even need this thing, and we've just reduced everything down, and we just import the directory. That's how the Odin system works, essentially. There's more interesting things here, obviously, but that's how we're getting around it. Now, we disallow import cycles, but that's because you want to clearly define what a package is. You're now getting these different things going on in here, and it's like, oh, okay. And hopefully this makes sense, right? Because the whole point is like, yeah, some people say, yeah, but I really want a file. I only want one file for my package. Why do I have to put it in a directory? And I understand that. But then literally like 3 months down the line, I'm like, yeah, I thought you only wanted a file for that package. Well, I needed more. I'm like, it's every time. It's like, unless it's a very small thing. And then even then it's like, did you actually need a package? Like, are you reusing that code again? Because this is something another people always think. They like making taxonomies. Don't add a taxonomy if you don't need it. And most of the time you do not need taxonomies. You already have a hierarchy there. So one thing I always recommend people do in Odin is like, for your project, just have one giant package. Like you're not going to have namespace collision most likely. And you're not reusing any of that code for your project. You can then split things off into multiple packages for reuse if necessary, because a package is a library. This is the thing, is in Odin, a package is a directory. It is a library. It is not a taxonomy. Oh, that's not even the right way of writing. Taxonomy. Stop writing taxonomies, okay? Please, please, can you stop doing the taxonomies? It's not good. That probably never answers your question specifically. I have no idea, but we're going to find, well, hopefully that did. Oh, we've got some other questions. Is there a colon equals and equals in Odin? That is correct. If you want more questions about syntax or even stuff, I recommend just checking out the Odin website. And there's a lovely FAQ that answers that specific question already, because guess what? It's commonly asked. So there is the stuff on the FAQ. And if you want, what is colon equals mean straight away? Like there is an FAQ, like not that. That's so many. God, what does this mean? Go to the syntax page and you can answer all the syntax questions that you need. And there we go. There we go. Problem solved. Other things, but. Someone says, I mean, null is being exactly equal to 0 is useful though, especially if you go with C's definition of Booleans. So no, in C++ and even C, anything that has a truthy value to it. So pointers have truthy values, integers have truthy values, Booleans have truthy values. So being 0 isn't helpful. Like pointers already had a truthy value to them. So it's a really bad definition. Like welcome to C++ hell. So the colon equals is, yeah, so Odin's package system is similar to Go. Similar, yes, it's not exactly the same. So we do actually try and improve a lot of Go's flaws in that regard. We still do have like the package declarations at the top. And the reason why we do that is actually for ABI reasons. So we have consistent ABI. LLVM, sorry, Go doesn't do this. Sorry, just flipping names. Go doesn't do this because it doesn't need to. It has an absolute like import path. Odin does not have an absolute import path. It has relative paths, and it's either relative to itself or relative to the library collection that you've specified. Yeah, like the name library collection. Like a name library collection would be like core, and then you do fumped. That is there. Or you've got vendor. Yeah, and then you've got SDL2. Like these are. This is, and it's not like do SDL2 like TTF whatever. So this is the library collection in Odin. This is the directory relative to the library collection that you're importing to make that package. Make sense? That's what it is. And it's a beautiful solution because it solves actually another problem that happened in C. So Go didn't have this problem because Go just went, everything's absolute to the Go path. I know Go mod now exists, but effectively everything is still relative to a virtual Go path. So that doesn't help. Everything's absolute. C, which is where the solution I'm solving comes from. In C, when you do an include, yeah, you have an include, and then we do a let's say f.c, yeah, whatever. I'm doing f. I don't know why. This is relative to the local file, yeah. Include. My handwriting's awful on this tablet, but if we do include f. C, this is an absolute import, and it looks through this import path list, which is horrible, and it's the first one it finds. It's dreadful. Oh my god. So Odin's import collection, library collections are the solution to this. It just goes, either if you don't specify one like you do like foo, this is relative to the current file. If you put a import path in there, it is relative to that specified collection, and you can have your own custom collections as well. But this solves this problem here that C had, which is dreadful. Hopefully that makes sense. And you're just trying to solve those particular problems that we had in programming. This is the whole point of Odin. You design the problems that you solve. You look at the problems and you solve the problems you actually have. Not problems you think you have, but the problems you've actually had, and try and find a way to do it. Sometimes there's no nice solution. Sometimes there isn't, unfortunately. But this is hopefully a good one. Taxonomies. So no, taxonomies are, for people who may not know that terminology, maybe you may know the word taxonomy from let's say animal kingdom stuff like this. So let's take this image. This is a taxonomy, like the domain, the kingdom, the phylum, the class, the order, the family, the genus, species. Like, we are Homo sapiens, so our genus is Homo, and our species is sapien. Yeah? That's the species thing there. And then we have family, and then order, and all that's like, we're all mammals, all this stuff. This is a taxonomy. There's no point adding an artificial taxonomy when there's already a hierarchy there. It's just not explicitly defined, but there is a hierarchy. Do not explicitly add another one on top. This is where people like making taxonomies because they think they're organizing stuff. And it's like, you're not organizing, you're making things worse for everybody else. Just stop. Just stop with the taxonomies, please. It's not good. It's not good. But yeah, hopefully that helps. Hey, another first time chat. Welcome to the chat. Maybe, hey, loving Odin. So far, been using it daily. Any plans on having some 3D vendor support? Having some 3D vendor support for import export. Oh, you mean? Oh, I mean like meshes. So maybe. But the thing is, this is where things get a little bit funny. Not everything is always doable or even a good idea. It's like I wouldn't want async. Async's not great. And in practice, when you actually do all this, it's hard to know. I might do a wavefront like object file reader. That might be a doable thing, but we might not do much after that because there's licensing issues is one thing, but also, good God, like FBX, you have to use the Autodesk library. You can't just make your own reverse engineered one. It's hell. You have to use it because it's so bad of a format. Collada, just don't use it. Alembic, I had to reverse engineer that myself, but that code is now for Django FX, not for public use. But I did write an article, so you could probably figure out how to write it yourself. God, it's just, yeah, it's a pain. 3D file formats are awful in general. Like, after you've used one, you'll probably make your own. If you're making a game or something, you probably just have to make your own anyway, because you want an immediate format specifically for your stuff. It's funny, but that's how it works. I know how long campfire stream with no program. It really is. It really is. And there's no campfire, unfortunately. Sad days. Informed thanks. Haskell eventually opted ML's mixing modules and recursive linking. Was curious if it... No, we don't do that. Again, it's one of those things where some people say like, oh, only Haskell has proper module system, don't you know? And it's like, first off, no, it doesn't. I don't care what you think a proper one is. It's just stop doing and no one in the chat saying this, but I've seen so many people say this, like, stop doing the no true Scotsman fallacy. It's annoying. But also, like, do you know what the problems you're solving? Because you might be making things worse. Like, Haskell is not nice to work in a big code base on. In fact, are there any? There's not many. There are, but there's not many successful Haskell code bases which are big, and for good reasons, because it's not that useful. You want to deal with. So yeah, the hexa format's in there because that was so easy to implement and it was well defined. Like, that's why I wrote it. I might do OBJ, but like, this is the problem, is that certain formats for like that are really, if they're easy to write, we should probably add them. If they're not, they're not. Yeah, people say this. Yeah, Haskell's module system is terrible, but people say it's a proper one. Don't talk about it. It's like, only because they're talking it from a mathematical standpoint, not practical standpoint. This is why Odin's, I've tried to make it the best as possibly can, which is it's a directory. You have files in a directory. All the files can see with each other because they're part of the same scope of the package. Then you import the directory. There is no such thing as a sub-package. There's only directories. There's no need for a hierarchy. The hierarchy is for organization, not for flipping, like, oh, sorry. It's just, there's a lot of code bases I've been in and they're just bad, if you didn't guess. And even the best ones, like even Python, some of the Python ones I've seen are nice. But the problem is they're just so hierarchical. Like, you have to import this ... like 5 levels deep to get the thing you want. It's like, why didn't you just have this on the flat base? It's not colliding. The name is not colliding with anything else. Like, what are you doing? Like these things are meant to be like to have namespaces so you don't have like namespace collisions. But no, you've just formed a taxonomy. Oh. Now I've told many people here, you'll probably see it everywhere. It's one of those things that once I've said, oh God, it's everywhere, it's everywhere. I know it really is. Not done in 3D so far, but everyone makes their own format. Sounds like a horrible domain to work in. So no, it doesn't. So I'll explain what I mean by this. When you're making like a game engine, you have specific things. Like if you have a custom game engine, you'll have custom formats because it's specific to what you're doing. And making a little format isn't difficult because usually you just have the thing that the artist makes, and then you pass that through to the converter, to the actual game engine usually. And this is how many things work. Or you write a plugin for your format in the thing. So it sounds like it's horrible. It's like, your artists don't actually, it just works for them. Like you just do this and then you want it to be a custom format because those interchange formats aren't small. Those interchange formats are that. There's to be interchange between different programs. They're not meant to be the final thing which you can then deal with, because the final thing is going to be heavily optimized. It's going to be small. It's only going to have the data in it. It's going to have extra metadata for what you may need it for that game or that program or whatever. That's why. So it sounds like it's not horrible. This is actually what the problem you're solving is. Like, that sounds horrible. Making a format's easy. That's the thing. Making formats is trivial. The thing about standardization is so you can talk about towards different programs. If you only have one program it reads from, it doesn't matter. It's standardized for that program. I do recommend people writing their specifications for their formats as well in your code. That's a really good practice to do. Don't just like, oh, don't do it. Like, it's useful. Yeah. The interquake model format is quite nice. Yeah, it's what I learned quite a lot of things from that from back in the day. That thing. Isn't Alembic open source? Yes, but I couldn't even get their library to compile on many of my machines. None of them. It would always compile and be corrupted every single time. So I had to reverse engineer the damn thing. So I even wrote an article about this, reverse engineering Alembic, and we did it for Alembic and stuff. And fun fact, the thing I wrote is a really simple format. The scheme is a bit weird to reverse engineer, but my thing is so easy and quicker than the actual original one. We're loading things like that. Like literally instantly. It's like 10 milliseconds sometimes or less just to load the Alembic files, even the big ones. Because I just dump it all into memory, read it, pass it through, convert it to our format, internal format, because it always have an internal format, and then you're done. Magic. Who'd have guessed? Alembic's not the best file format in the world, but it's just it's fine if you want a different mesh per frame. And that's what it is. Or you have a single mesh, but it's a static mesh. It's either static meshes or different static meshes per frame. It's not for animated meshes. Alembic is not for animated meshes whatsoever. It's for particles and static messages, or animated static messages, or different mesh per frame. Like it's simulating fluid simulation or whatever. So just because it's open source doesn't mean it's good. And also it's just like, it's not documented. It's not, like, the format is not documented. And that's fine. Like, but by the way, I now know why. I remember I actually, when I wrote that article, one of the creators actually emailed me about it. Lovely man he was, absolutely. And he was just telling me why. And it's just because of like reasons of the company structure and political reasons, all that lot. And that's why it is the way it is. That's okay. So do an A and B share a namespace? They share a scope. Yeah, they share a namespace. They have their own as well, local. Like they have local file for certain things. You may want that. But most of the time it's just like, yeah, A and B share a package space, the same scope of the package. That's why they can see each other. The files are just for organization most of the time. That's what people want it for, and you solve that problem. Now, many people will first start it with Odin and their package system. You may get confused, and you go, oh, that's a bit weird. I'm like, yeah, but about a week or two after you've gotten using it, I don't like this, and you go, oh God, I love this. This is the best way of doing things. And it's like, yeah, because you're so used to an older way, you may think, oh, I just don't like it. Because this is different. It's different, but it actually solves pretty much all your problems, unironically. That's the case. You were a rough FBX loader. Yep, I've written one before partially as well, but it's reverse engineering it. You're not actually, how do I put it? It's not actually known what the full specification of the format is because it's closed by Autodesk, and it may be buggy, and you may not have everything because it also FBX has ASCII files within it as well. It's not just purely binary, and it flips in and forth, and it's like always nightmare. I clearly can tell I know a lot about formats because I've dealt with these, and they're just bad. It's not even difficult to write a good one. I don't understand how these industries make bad formats. I don't. Like, I do actually, but also at the same time, it's like, no, you should just have one person design it, maybe two max. No more. That's it. If you can't design it in a week, you've done something wrong. I mean, design and implement it in a week, you've done something wrong. That's what I mean. And yeah, sorry. I think we're going to just call this end of a stream now because I've got other things to do today. As in, feed myself and clean the house and the kitchen and other things like that. So hopefully this has been enjoyable. This has just been a chat stream by the looks of it. It's not even programming, mainly because the programming stuff I need to do is other stuff which I'm not going to be productive on stream anyway. But yeah, so I'm just reading through the chat that you like the old Dune 2 pack format. This is Kalimian, which was one of those riff-like type, offset, length, file formats. The traditional has been carried forward to the MP4, and they're very simple to pass. Yeah, they really are simple to pass. And it is very weird that MP3 was, until recently, had a patent on it, which is funny because it's like, this is why I'm not a big fan of software patents in general, because most of them are just daft, like really daft. You can say that against patents as well in general, but like software patents are really daft, because it's so much like, yeah, but you will pretty much rediscover something that's already got a patent on it. It's like, really? Like literally even like a beginner program will do something. It's like, no, this has got a patent on it still. It's like, what? Yeah, it's just, and also they'll have patents for some things that don't make sense. I can understand patents, hypothetically speaking, for software where you got something really complicated like this, a really complicated error, and it's very specific to a problem, but not like a generalized one, like, oh, we've got a patent now on a hash map. Yeah. Like, and not, that's exaggerating, but there was a patent on like auto-relative pointers for a while. In the US at least, luckily. But like, what? Like I've seen them exist before that patent existed. This is the problem: is the patents will be just given out, even if you can go like, well, this existed like decades before. Says, yeah, but we couldn't find it. I'm like, what are you doing for your job? You're not doing very well as a patent clerk now, are you? Believe in hell. You're not sure if your domain is worse or better, and you have a giant XML format where each node has 3-letter combinations that not even resemble what the node means. Yeah, XML is bad. I mean, I've seen worse. XML can be bad. At least you can have an XML parse, and XML is well defined. Your former employer has a patent effectively on compilers, so better watch out. Oh, no. I'm like, this is the thing about certain patents like this, is if they ever did try to get enforced, and you go, yeah, no. But a lot of them do, and it's like, you have to pay them. It's like, luckily, I'm not in that country. I'm not in America, I'm in England. We do have the very rare software patents in this country. I wish we didn't have any, to be honest with you. But that's a different thing. There was a patent on arithmetic coding, which is the first thing to think of to improve Huffman coding. Wonderful. Yep. This is why it's like sometimes the most obvious things have patents on them. And those patents last a long time as well. So Apple's suing fruit companies for having logos. So that's not patents, that's trademark. And with trademarks, this is actually kind of thing. So you actually have to enforce your trademark, otherwise you lose it. If you do not enforce your trademark, you do lose it. And that's kind of the thing. So in that case where they're selling fruit companies, like, yeah, I can understand it, but they'll still take it to court. Like they're showing they're enforcing it. So I'm not saying I'm defending that. It's just how the legal system works in like common law systems. But yeah, okay, I'm going to call this an evening. I doubt I'm going to stream later this evening again. I could do, but we'll probably try and stream tomorrow, obviously, because it's going to be streaming all week kind of thing. And it's been quite fun doing all this, actually, by the way. It really has. So hopefully you've all been enjoying this. Thank you so much for watching. Please make sure to follow, I think. Like, is it here? Is she going to have to follow? Or, yeah, it's going to be right here, even on YouTube. It's here nowadays. Blimey heck, it's been a long time. At least I'm not pointing to here to follow. Now that looks like I'm showing my age on YouTube. Clearly. Like, click that yellow button to subscribe. No, it's not there. And like, the doobly-doo went from there to there. It's like, oh god. This is really, okay, this is showing some stuff. So, which question was your question? I'm sorry, I didn't see it. I must have missed the question, Hikari. Which one was it? Please answer the question again. Sorry. I really didn't see it, but thank you. Yeah, make sure to like that smash button. I've said numerous times if you're on YouTube, obviously. If you're in Twitch, remember to follow. Is that the heart? I don't know what it is. I don't know the things about Twitch. Please teach me it, because I don't know the Twitch ways. Oh, defer implementation. You should have read 3 comments up. I posted the link. I thought that answered you already. Like, literally, your question, I thought I gave you the link 3 comments up before you even asked it. So yeah, there you go. So I answered your question before you even asked it. Oh no, the different one is, yeah, it's only slightly different. Like, it's effectively the same. So I wouldn't worry. Yeah. But there you go. Okay, good night, everybody, or good evening, or good morning, or whatever. Good afternoon. So, see you, everybody. It's been a good stream, I think. Yeah, stay tuned for the next one. Probably tomorrow. Probably similar time as well. Bye.